So hi everyone, thank you everyone for joining. It's really great to see you, and so many people joined. So today we are going to talk about our JavaScript API. In the last meeting, which was actually 4 weeks ago, we discussed different extensibility options for Datagrok, how packages work, how integration with other languages works, what you can do with scripts, and so on. We discussed the concept of first-class functions and how we utilize it to make the platform really infinitely extensible. So today we are not going to repeat that. In case if you need a refresher, there is a link to the presentation and the PowerPoint available on our community site. So yeah, please visit it. Today we will be talking about JavaScript API specifically. So let me share my screen. All right, you see my PowerPoint, right? I have multiple screens.
Yeah, we can see it. Yeah.
Probably no reason for me to do video. I always wonder how it looks on the other side, so I hope the picture is clear to you. Okay, so that's what we discussed last time, and there is a link which you can follow to get a refresher. So today we will be covering the topics of what is JavaScript API, how does it work behind the scenes, because this is important to understand what's possible, what's not, and how much effort is involved on our side in order to expose and maintain the API. Then the API itself, and that includes the rationale for how we built it and different entry points, how you can interpret with the system. And then, of course, we will try to do as many demos and samples as possible. Please do interrupt me at any time. I'll be happy to answer any questions. So either just ask or enter the question in the chat. I'll try to pay attention to it. If I miss something, so please remind me too. All right, so first of all, I just wanted to mention the different references that you can use later. So the main resource that is useful for understanding the API is our code snippets. So let me actually click on that. Of course, it opens on the other window. So it contains a bunch of JavaScript API snippets that are categorized already by the domain, and there is a nice hierarchy to it. Every sample is executable and it's isolated. So we try to isolate each concept and produce these little snippets that illustrate different aspects of the platform. So for instance, I would go to data frame, which is our data engine, and aggregation snippet. If I run it, it produces the result. So it's really nice. On one side, it's a guarantee that it works as expected. It's also self-documenting. What I also like about it is that it's really easy to just copy and paste this code to your project. So it's really a tool for development. Then, of course, there is a community. I hope you are already familiar with that. We try to keep the discussions live there. Then there is help. system, and in particular help on our JavaScript API. It will contain pretty much what we will be talking today in a structured manner with all the necessary hyperlinks. So it's always an option to check it here. Another good resource is our public repository of plugins, which is on GitHub. So check it out. Whenever you want to see an example of how anything is really implemented, you can just go ahead and check each of the packages. For instance, this is the Leaflet geographical map. So we would just go deeper and go down to the sources. So if anything interests you in our published package, everything is publicly available through that GitHub repository. So, yeah, pretty convenient.
Andrew, this is Dimitris. Who controls the naming of these things?
Naming of classes?
Packages and things, yeah, all of that stuff.
Mm-hmm. Well, we have a convention that we encourage people to follow, but we do not enforce it. So essentially, it's a camel case convention for classes. There is some namespace for data group classes, and so on. Is that what the question was? For?
No. Go back to the previous screen where you had all the packages.
Mm-hmm.
There you go. Just stay there for a second. I mean, over time, this will become a big mess.
Right. We have already agreed on a hierarchy. So there will be things like Chem, ML, NLP, so on and so forth, so that you'll be able to drill down to it. Also, the hierarchy will serve as a source for metadata, which is a separate topic, but I just wanted to mention it. So users in the UI will be able to, for instance, when they search for functions, they will be able to apply a tag, for instance, Cheminformatics, which will be bound to a particular level in the hierarchy. So we are thinking about all of that.
I'm wondering, I'm sorry, I don't want to monopolize the spaces. I'm wondering, though, if a supervised version of this might be preferred, where you or somebody advise every contributor on name of the packet, naming conventions, hire all of that stuff. Is that, I don't know, I don't want to speak for everybody. It's just a thought that I can see this getting out of hand basically very quickly.
Mm-hmm. I agree with you. We probably will use some combination of just reaching out to people individually and maybe some form of automated checks to make sure that they adhere to our conventions. So yeah, essentially it will be the App Store, but not so draconian as the Apple App Store, but probably it will be good for people to follow recommendations.
Okay, thanks.
Yeah, again, we don't know exactly where it will lead us, but we are putting some measures already. All right, so what's the JavaScript API? We did discuss Python scripts, R scripts, SQL scripts, Sparkle, and other ways for extending the platform, which are useful. They are super lightweight. And also, by the way, running utilities that we just did with Dima a few weeks ago. It's nice and useful, but of course, it's limited. And JavaScript API is the opposite. It is intended to provide you complete control over the platform, both on the client side and on the server side as well. It involves pretty much anything you can do with the platform, starting with data ingestion, visualization, all sorts of computations, registering functions that could be used by different people or even by different packages, and writing applications on top of it. So now I want to explain how it all works. So as you might know, internally, our platform is developed in a language called Dart. It is a language that Google came up with probably 7 or 8 years ago. It was designed to address all the deficiencies of the JavaScript language and provide a modern, manageable language that could be used in both server side and client side. So on the client side, it compiles to JavaScript. So we get tons of benefits from using Dart. Again, it's a really nice language, powerful tools and everything. But on the client side, the language, the standard language of the web is JavaScript. So this is why we have to provide some sort of interoperation level. And now I just want you to see an example of how we do that so that you get an idea how difficult it would be for us to do some stuff. By the way, do you see the font fine, or should I magnify it? All right, so I assume you can see it. So here's our...
I was muted. That was a poor assumption, man. Just bring it up a little bit. Hey, can you see poor Walter there?
All right, sorry. Let me just quickly increase the settings. So font, I think. Let's do it. Better?
Very much.
Okay. So we see a glimpse of how the code looks in Dart. So we have probably 500 classes or so. I don't know how many exactly, but a lot. And a lot of code that does many different things. For JavaScript, we do not expose everything that we have under the hood. Instead, we expose a level of API that we think provides some basis for doing pretty much anything in the platform. And this is how we do it. So let's take a look at one of the core classes in our platform, a data frame, which is a part of our in-memory columnar database. So this is the Dart code. I'm not gonna stop on it, but that's how it would look like. Then there is a translation layer that exposes particular methods from Dart into JavaScript. So technically, we are registering references to functions in the window class, but this is how it looks like on the interoperation side. We are exposing particular methods and calling them from Dart. Then on the JavaScript side, what we did is we translated most of the core classes and created their analogs in the JavaScript space. So this is the same class data frame now in JavaScript. The way it works is that it operates on the instance of the Dart instance, and it marshals the calls to the Dart code. So on the surface, it looks nice. It does appear like a first-class JavaScript object with a good API, but internally, all the calls are getting translated to Dart. So this is the idea of how it works. There are many other more complicated techniques such as event management or asynchronous programming, but on the surface, that's how it this is how it looks. So in order for us to expose something else, we would need to create typically a JavaScript method or a class and write and maintain that translation layer. So having that translation layer has both benefits and also downsides. So the downside is that there is an extra layer, obviously, which we have to maintain, but there are benefits. And the benefits are is that we have additional control over the API that we expose. What we try to do is we try to expose on the stable API and to keep the API in a way that no major changes are here. And because we have that translation layer, we have another level of flexibility while doing so. Okay, if there are no questions how it works, I'll proceed further. So the overall API design. So we had pretty much complete control over how we wanted to design it. And that's what we tried to do. We tried to keep it really simple and simple in any possible way. Methods should be very clean, concise, parameters should be understandable. There should be both all parameters and return values should be strongly typed if possible, which is doable in JavaScript using special sort of documentation. The code really needs to be expressive. It should read like an English sentence if possible. Then everything should be discoverable. We do not want to expose people to just 150 classes of JavaScript and tell them, well, we can do everything, here are the classes, right? It's a mess. So instead, we came up with the idea where there are certain entry points to the system. And then using the IntelliSense, you can explore the functionality in an interactive manner really quickly. And you'll see it in a demo really soon. Then the platform should be, and the API should be fast. You probably figured out already that we do not take any compromises regarding the performance. And we did keep both the expressiveness of the API, but also we let people dive deep to the very lowest level of our implementation. So for instance, our data engine, if necessary, exposes all sorts of bit mask, bit fields, raw data stores for arrays, and so on. So if you need to, you can work at maximum speed with that data. So for instance, if WebAssembly, some of you might know about it, is an emerging, very promising technology for the web, which is really performant, but also it has support for multi-threading. So by exposing these internal arrays, it's possible to write a really efficient implementation of algorithms and run it within the browser on the client completely using C++ code if necessary in parallel multi-threaded. So that's pretty much the holy grail of computing. You don't need anything more than that once you could do that. And this is one of our goals, to provide people with as powerful machinery as possible. Lastly, we did want to take advantage of our platform integration. So we'll see during the demo different things where, for instance, there is a special inspector panel where we can inspect events coming out of the system and not only see what's going on, but the inspector will also automatically produce the JavaScript code that would be necessary for handling such an event. So we just decided to integrate the user experience and development experience in one product. Of course, if you are a developer. If you are not a developer, you simply will not see all of these widgets that we will be also showing. So here are three main entry points that I mentioned to the platform that we built for the easy discoverability of our functionality. The main entry point is called grok, which is a variable in JavaScript. You can type grok dot either in your editor, your IDE, or even in the browser, and we'll see suggestions for what to do next. Then, actually, it will be a good idea to demonstrate how it looks like. Let's see on browser. Okay, so here's our API examples. So, for instance, this is one of the scripts that loads all the projects that have demo tag, and then creates a view that renders these projects as a card. So that's really a four-liner which uses that Fluent grok API. So let me just run it to show you that it works. Indeed, we produced all the projects. And this is how you would, it's possible to edit a code like that. So in this particular case, I'm not even using any editor. I'm just using the built-in Chrome capabilities. So once I type grok and put dot, we'll see different modules exposed out of grok. So for instance, if I want to use anything related to our server API, which is DAPI, I would call DAPI. And then we'll see suggestions for what to do next. So, for instance, if I want to do something with models, I would also type dot. And yeah, in this case, it did not put suggestions. Probably we missed some declaration. But it will work exactly like that. So you can chain methods. Oh, I know. That's because it executes it right in the Chrome. They will appear in the API, in the IDE. So you can chain methods and expose explore the capabilities of the platform just like that. So you don't really even need an IDE unless you really know what you're doing and you want to use it. We also plan to integrate our built-in editor with the IntelliSense much further. So currently it highlights JavaScript code. By the way, it does the same with R, Python, and other languages. But we also want to have a first-class developers experience right in the browser. But this functionality is coming. And there are multiple submodules within grok. Yeah, for instance, chemistry or machine learning, natural language processing, and so on, which are easily discoverable. The next major entry point is called UI. So this is used exclusively for building user interface quickly, so that instead of creating all the classes manually and calling all of the methods on all of them, it's often possible to just start building something, then chain methods call that would do what you want, and then complete it with some action. So for instance, in this case, we are creating a dialog, adding some content to it, adding a handler to that dialog, presumably it deletes something, and there is a missing parenthesis, so it's not a working code, and shows the dialog. We've also exposed a number of different widgets, such as all sorts of accordions, choices, combo boxes, and so on, which are available from that UI entry point. Of course, we have hundreds of, probably less than 100, about 100 examples in our platform related to that. So, examples for adding menus, adding some icons. Well, it does not look good, but it does what we're doing. All sorts of tooltips, internal controls like tag editors, our internal tab controls, and so on and so forth. All sorts of ribbons, constructing views. So everything that you see in our native DataGrok UI, you can do with JavaScript in that easy manner. It's also possible to integrate any other technology into it, such as, of course, you can easily add native HTML widgets that you can create in any standard way. Or we can integrate with libraries like React, and there was an example somewhere. Don't know if I can find it, but yeah, there is something. So essentially, we provide the API that lets you do anything on a low level if you want to, but also we provide nice standard controls that would look and feel in a native way that are also integrated with the platform in different ways. And the third entry point, or the third way to explore the functionality, is a big namespace called DG, which of course stands for DataGrok, that contains all classes that we have exposed in the JavaScript. So there are probably about hundreds of them, or maybe slightly less. So things like our data engine or certain elements of the UI. All of them are there. It's possible to start instantiating these classes and calling their methods. Internally, these two entry points, they use classes from the DG namespace. Sometimes you would need to use them directly for certain tasks that are more exotic, or for something that we did not provide that fluent API for. So the philosophy here is to provide an easy and findable way for doing common things that would read as an English sentence, and also provide the flexibility to do anything your way if there is a need.
Hey, Andrew, Dimitris again, can I ask a question?
Mm-hmm.
You said that from the DG, you also access UI elements. So is there a difference from the UI versus the DG entry point?
No difference. So UI is just a nice way for building interface. Essentially, you type UI dot, and you see all the visual elements that could be quickly built. As opposed to when you enter DG, and you'll see 150 classes.
So you haven't suborganized. Okay, so you don't say dg.ui dot and then you go down to the rest of it.
No, we don't. Yeah,
Okay, I got it.
Yeah,
I
right.
got it.
We can if we want to, and maybe if the number of classes will explode, we might. But currently, we try
Okay.
to stick with those three things.
Okay, sounds good.
And there are certain prefixes also that can help you. For instance, we have data frame, data row, data column, things like that that can also be helpful. Okay. Another popular question is how we handle events. To inside in Dart, we have a really nice ecosystem, a really nice library for handling streams of events. It's built in the language. It's beautiful. You can compose different streams of events. You can introduce all sorts of poses. It's very convenient for things like implementing type aheads. So we really loved it, and we thought JavaScript developers would benefit from something similar. And such a library exists. It's called rx.js. Actually, Microsoft implemented it. I believe originally it was for C#, which we've also used a lot in J&J. So what we did, we've included that library. It's not big in the core. And we exposed all the events using that library. So essentially, all events become observables, and it's really easy to interoperate with them. So, for instance, data frame. Let me do. Yeah. In this example, we are creating. Let me magnify it for Dimitris and Walter. We are creating a data frame, and then we are listening to its events. And of course, you see it's already all events have a name and a way to subscribe to them. And essentially, it provides you a manageable way to handle events. You can merge those streams and do different things. So I will not will not cover it in details, but it's a really nice way for handling it. I'll just run the example. And of course, yeah, whenever I click or change something, there are tons of events being generated, which you can handle in JavaScript code and yeah, interact with that particular data frame, intercept events. Some of the events, it's possible to prevent the default implementation and instead react yourself on that event. So it's really a first-class concept that we did. Another thing that I will mention, I mentioned it already. So we did provide an integration for special extensions for developers. So this is the inspector that I've invoked by pressing Alt-I. Well, there are other ways to launch it, but I'll just... and in the client log pane, we see all events that are coming from the system. It's also possible to attach to a particular instance, such as a data frame, but in this case, we are tracking global events. Moreover, not only you see the events, you can click on each of the event and inspect its details. So in this particular case, the current object of the system was changed, that there is some internal ID and default action is not prevented, and current object is not shown because there is no renderer for it. But also there is a JavaScript code generated for handling that particular event. That if you are interested in it, you can just copy paste and use in your JavaScript. So a really nice way to figure out what's happening with the system. And by the way, if you will be developing for Datagroup platform, you might find this inspector quite useful. It has all sorts of introspective capabilities, such as figuring out which events are currently firing, what's happening with the server. Yeah, that's the server log. You can inspect your local storage, figure out exactly what's happening with the current column, how your current project represented in JSON, how the current view will be, or a viewer will be represented as JSON, useful for debug purposes, and other things, how long different functions take, some benchmarks, performance benchmarks for different things such as serializations. You can figure out what's currently visible on the screen, which widgets are visible, how many elements are there, how many times you have subscribed to global events and not unsubscribed. Things like what are the supported handlers for file importers, which metadata providers are registered, and just other debug-related things. So I'm pretty sure if you will develop for it more or less seriously, you will find it quite useful. Okay, so I also wanted to highlight certain samples that we have in our samples repository, just to give you a sense of what's possible with the platform. So I started with user-defined classes. So it's completely possible to design your custom class in JavaScript and integrate it natively with the platform. And what it means, I'll explain right away. Let's go to JavaScript samples. Okay, so in this example, we are defining our class, which is a dummy class called fruit. And what's more interesting, we are defining a class that extends one of the Datagroup standard classes, which is the JS entity meta. And by overriding the corresponding method of that JS entity class, it is possible to define a behavior, the way how the platform should interact with the class, how it should render it, interact with instances of that class, how it should render it, how should cards of this type look, how should tooltips look. It will support things like making this object current or drag and dropping it out of the box. So, and all that you need to do is really only define what you need to. So with what's 3 lines of code, the following is possible. So see what we are doing. We've defined the class. We've defined the metadata for that class. Yeah, that's important. Important method. It checks whether this metadata class is applicable to something. And then we would define different things. In this particular case, the way we render it. And there is one method that we register that operates on instances of that class. Then we register this meta class, and then we render 2 different fruits. 20 lines of code, and look what's happening. So as promised, we've rendered 2 instances of fruits. When we click on each one, it shows us custom properties. If you remember the script, yeah, that's what gets executed. We are creating a div element. Drag and drop is supported, so we can start dragging. Oh, unfortunately, I did not override the render tooltip method. Otherwise, we can also provide custom way for rendering what's being shown. And also, if this object supported, you might drop it and save it in your favorites. So a really native way of integrating it with the platform. What's probably more interesting is that once you right-click on it, we see context actions applicable to that object. And if we go back to our script, we did register an action called eat that will simply show what we just ate. So we would right-click and execute this method right away. And I find it extremely powerful. Typically, things like that take a lot to develop, and it did take us a lot to develop. But now, to people developing on top of the platform, this functionality comes out of the box. Okay, so I think we got some questions or not.
There are some on the chat window.
Okay, I see. So a question from Alok. Have you considered writing the translation layer in TypeScript? This could make it easy to provide a typed interface alongside a JavaScript API. Yes, we did consider it, and we are still considering it. So personally, yeah, I love the more type information we can provide, the better. Yeah, in short, we are still considering the best way for integrating with TypeScript. Of course, we do not want to lose that integration with JavaScript. Oh, so the question, oh, sorry, Alok, that the translation layer. Yes, that's slightly.
So yeah, I guess when there are a lot of libraries that are written in TypeScript that are then easily usable from JavaScript, because when they're deployed, they get transpiled to JavaScript. So yeah, so I don't think you lose too much. I haven't actually thought too much about exactly what you gain. It just occurred to me when you're showing the Dart code versus the JavaScript code, it seemed like it would be an opportunity to preserve those types.
Yes, exactly. So we did consider that and many other options, and we are still trying to evolve it. But our existing API will not break if we manage to do it in a nice way. We will just get the ability to write in TypeScript even easier. So Dart is a lot closer to TypeScript than it is to JavaScript indeed. So it will be a nice feature that we hope we will provide. Also, we are hoping to provide the capability to write scripts in TypeScript. In this case, of course, they will not be executed on a server immediately. They will get transpiled to JavaScript on a server. But since we have already a powerful backend infrastructure on a server, this should not be a big issue, and it transpiles really quickly. So I think we will eventually do it. And of course, it's also possible to write plugins in TypeScript, which is also an area. Well, we don't even need to explore it because it produces JavaScript code, but I think it's a useful way for writing complex applications better than JavaScript. Okay. Yeah, then we do have examples for different domain-dependent stuff, such as, for instance, this small script will open a CSV file and will calculate a number of chemical descriptors. So we have JavaScript API for different domains. So we have a lot of things for Cheminformatics, by the way, including iterating over atoms and bonds if necessary. Currently, we use OpenChemLib, but as some of you know, we are collaborating with Greg Landrum, who's the author of the RDKit. So we will be providing first-class support, first-class RDKit support in Grok. And by first-class support, I mean we will be running all of the chemistry right in the browser. So this capability is also coming.
When will that be available, Andrew, you think?
Some of it is available already. We have a demo and a plugin that loads RDKit as WebAssembly and renders molecules to SVG. So that functionality is available already, although it's not implemented with the grid yet. Implementing it with the grid is coming in the next month, and then it pretty much depends on Greg Landrum and the way we will proceed and what we will agree to expose. Well, we have a meeting scheduled with Nico and I think a few other people for, I think, in 2 weeks or so. So we'll get a more clear picture. And I already spoke to Greg a few days ago. So
okay.
yeah.
Can I ask another question? That's not my space. I don't know it as well. Perhaps Alok may be able to help. Do you plan to incorporate a bioinformatics toolkit? Remember what we did with MBF with Jeremy and the molecular biology, the Microsoft Biology Foundation or something like that?
Mm-hmm. Yes, absolutely. We did delay it a little bit because we were hoping to hire a guy, an expert in bioinformatics, who would do that for us. So that did not happen, at least that particular guy. Unfortunately, we did not hire him. So we will be looking into a good bioinformatics library that would run in a browser. So perhaps, Alok, if you have suggestions here, we are open to that. As you might know, we've already built a number of plugins that expose different capabilities, such as sequence alignment viewer and property viewer for sequences. But it's more or less ad hoc. It's just a proof of concept rather than the coherent ecosystem.
Yep. Okay.
But indeed, it is an area of particular interest for us. So if anyone has input, we'll be very glad to hear it. Maybe, who knows, maybe Arcadia can help here too.
I guess just from my perspective, there isn't a great bioinformatics JavaScript community. I think it's more like in R and Python, and historically in Perl. So even simple things like finding a good plasmid viewer component it has been tough. So.
All right. Yeah, I spent a few weeks on that long time ago. That resulted in us building this proof of concept viewers. But it will be good to explore it. We do have the capability, might have the capability to compile C++ code into WebAssembly, depending on how it's implemented. So let's keep it in mind too. Another capability that in bioinformatics, it's quite common to use utilities. And just very recently, literally a week ago, we've implemented the first class support for utilities in the data group. So now you can ship your Linux utilities with your package, and you'll get the ability to invoke them in as functions. So it's possible to run them in different contexts, and they would look just like regular data group functions. So perhaps this is another way to approach it. Yeah, of course.
I just pasted the link to MBF on the chat window.
Mm-hmm.
Just for you to, which brings me to an interesting question. I'm just curious. How would you work with C# code?
Mm-hmm. With C# code, so there are a few options. One of the options, actually 3 options I can think currently of. So one is to ship them as utilities. So C# you can now run on Linux. So if it's something that has a well-defined input and output, you can build a utility and write a very thin integration layer with Datagrok and use, which might not be very convenient.
That's not ideal.
Yes, it's not ideal, but perhaps it could be useful for certain purposes. Sometimes, it still makes sense to run things on a server. For instance, our server has 16 cores or so. So whenever we do computations of chemical descriptors, we run it all in parallel. So even considering that we are sending the data back and forth, it's still faster than if we would do it even in parallel using all local processors. So in some cases, it's beneficial. Another second way to integrate with C# would be to use C# to WebAssembly compiler. I know that such an effort exists in Microsoft. I forgot what the name is. Blazor. I think it's Blazor something, or something that sounds similarly. So it's possible to do with certain restrictions. Yeah, the third way is also using scripting, which will be more lightweight than utilities, but will still result in running the code on a server.
Okay.
Yeah, it's interesting. Currently, it's easier to run C++ code in the browser than C#. But many languages are getting there, so it is exciting. I see a question from Dima regarding Silverlight. No, Silverlight is a dead technology. But there is no really reason for Silverlight existence anymore. Now I admit it. Yeah, we do have capabilities, also API for machine learning, so I will not be stopping in details. Yeah, just explore the samples and we'll see the different ideas, including complete control of the rendering cycle. So we have that high-performance grid that is capable of rendering as much data as you want, billions of rows. It will actually work with million columns as well. And if you want to display anything in particular, yeah, we provide complete API for rendering on top of it on Canvas if you want to. There are also other ways to extend it using HTML cells or anything else. So there are a number of classes and integrations that are devoted specifically to customizing the grid, since it is so central to interacting with data. Of course, we also have a way to create completely custom viewers within JavaScript. So I'll just give you an example. So let's open some geographical data. It's 125,000 rows, and we will add a viewer called Leaflet, which is a JavaScript viewer. I've already shown a package in our public repository that integrates with it. So what's also interesting about it is that it is using our internal raw byte bit sets in order to interoperate with data. Because the viewer is already pretty fast, so it benefited from such a feature. So as you can see, it renders a heat map interactively. And yeah, we are talking about hundreds of thousands of points. And this is not even our Dart code, that's another viewer. So that's just a proof that it's possible to write high-performance code with zero overhead. It uses our internal buffers. Oops. Okay, and also we wanted to show you the way to integrate with the development environment in a slightly more complex fashion. So recently, and that request came from Novartis, and it was, of course, very important to us regardless. So we wanted to provide a really solid first-class experience for JavaScript developers. And that included everything, the way you install the interoperation, the way you would write your plugins, the way you deploy, the way you debug, the way you use IntelliSense, the way you reference other modules, and so on and so forth. So in short, we have answered all of these questions. And I think Alexander will briefly show you the way to do it and the way it's implemented currently. So Alexander, if you don't mind, yeah, please grab it.
Yeah, sure. Okay, I'm sharing my screen. Can you see it? Can you see my screen?
I can't, or maybe I'm using the wrong window.
I can see it.
Yeah, I think you can. You need to stop sharing your screen.
We can see Alex on screen.
Okay, super. So what we've done, as most of you know, that JavaScript development has some standards of code development. For example, everybody uses npm package management. Most of JavaScript developers use Webpack or another builder. And there are many libraries that you want to use, such as Babel or T3 or whatever else. So we developed a few npm utilities, a few npm packages to help developers build on packages. That system is working in parallel with the old package development system, and you always can get back to simple development, but I think it will be very useful for advanced JavaScript developers. So let me demonstrate. To start developing package, all you need to do is to firstly, of course, you need to install Datadog tools. That's an npm package. For those who doesn't know what is npm is the package management system that allows you to install packages, handle dependencies, and so on. Basically, it's JavaScript development standards, and you obviously need to use it if you want to develop something complicated. Okay, I have Datadog tools already installed, so I can just run Datadog init. It will ask some questions. And I need development key. I can simply get it in my user profile. Okay, and I'm ready to build a new package. This is a package template. Here's a package JSON that has already all dependencies, that has already scripts to debug and deploy package on public Datadog. It has a script to build. It also has build configuration and so on. So basically, all I need to do is to write the code. Of course, I can use any dependencies I want, so I can add here as many dependencies as I want, and everything will be built into single packages file on our server. So for basic scenario, you do not even need Webpack installed on the local machine. So I already built here some package that have the free dependency and that have a viewer built on using our JavaScript API. It's very complicated, but we're here to just demonstrate how it actually works. So to publish this package, I need to run a script. Now package was built on our server using Webpack, and basically that's all. So D3 is included inside our package.js. If you don't want to include some libraries, you can mark them as external. And if you know that Datadog has some libraries already included in the platform, for example, we have OpenCamLib and RxJS, and they are already marked as external here. So if I import RxJS library, it will be used from the platform, but not included inside the package.js file. And to test this package locally and to develop it locally without public.js, we now have a Docker container with Datadog and Postgres database inside. So we have Docker compose file available. It's not available on public now, but it will be soon in a couple of days. And basically with one line of code, I can, let me demonstrate it. I can execute Datadog, and it will be completely ready to local development. So I need to specify a local Datadog address in the package utility, and I can debug my package inside local instance of Datadog. And that's pretty much the same. Now we support JavaScript development experience that basically every JavaScript developer is familiar with. And you can include any library you want. So, any questions? Oh, I see that Dmitry not had questions. No, you cannot include the library directly in the browser, but you can develop a package that brings a library and then call a function from that package from the browser. Yeah. Okay, Andrew, would you take a control again?
Sure, yeah. Thanks, Alexander. All right, so I think in the next few minutes we'll go over different samples that we have, just to give slightly more idea of what we are capable of doing. Of course, yeah, feel free to explore it on our own, as well as the help, which we are constantly updating. So we can do things like exploring objects available from on the server, and this could be projects or users or credentials or queries, everything. So this grok.dapi is an entry point for doing that. Or we can do completely custom things, such as getting a current user and then producing a very custom UI for visualizing it. So if I want to show myself like that, we can run that script. For data access, so it's possible to do things like opening, for instance, a CSV file from some remote location, or opening a table by the identificator of the table that was previously uploaded to the platform, or things like running a query, which is a first-class object in the data grok. So that's the name of the query in namespaces with the parameters. So if you remember, a query could be parameterized in multiple ways. So all of that is easily doable from JavaScript. I wonder if that will work. Perhaps we, it does. It just did 645 results. Then for our internal data engine, you can do pretty much anything that you want with that you might want to do with a tabular table. All sorts of linking, comparing, joining, adding, removing, manipulating, so on and so forth. You can also operate with the filter and with the selection of the rows directly. So here's a little script that just imitates the streaming data in JavaScript. So essentially, we keep adding rows and removing old rows, so which imitates the stock data, which is random. Different domains, so we touched base on that already. Ability to handle events, we discussed it already. Then it's also possible to register different functions that will serve particular purposes. For instance, we can register a function that would return a viewer, and immediately it becomes available as one of the viewers available for the platform. So we don't even have to have a package. We can register it all dynamically as a script. It's really that easy. It can be really lightweight. So let me see what's happening. So that's the viewer that was developed in that little script, and presumably it follows some number of selected rows. It binds to the table. Again, everything that you see in the platform that you saw in the demos, such as information panels, anything like that, it's also possible. For our spreadsheet is completely customizable from the API, including the way you would render things directly or canvas, or if for some reason you want to, for instance, restrict the number of available values in a column to a certain range, you can do that, or anything like that. On the server side, we also provide a number of capabilities for developers. One of them is the data storage, which is controllable from the JavaScript API. So in case you need to store something specific to the user, there is a nice API for doing so. So I think this example does a lot more than that, because actually storing value and retrieving a value is just one call. So this one. So I think that's some API. So I'm not familiar with that sample. I was not the author. But yeah, it's good to know that you can always store stuff on the server per user. We do take performance really seriously, so we constantly have, and we do run it automatically, performance tests. So, for instance, if I want to, I can create a table with 1 million columns. It probably will take a few seconds, or no, I think that's that might be the broken sample. Let's see. Just in case, I'll open another instance of the viewer. It might be a little bit too much. Actually, I think I know what's happening here. One of the scripts that we ran previously was a script that inspects the contents of newly created tables. So it intercepted the addition of the table, and it started doing some serious checks against that table, which is huge. So we'll just probably exit that page. And of course, all sorts of things you can do with UI, including the additions and customizations of viewers. So in this particular case, we will be adding a scatter plot with some customization. So as you can see, there are regression lines that we set up in the settings and some custom marker. So I think at this point, I want to open it to the questions. We have 10 more minutes. Yeah, we'll be happy to answer anything.
Andrew, do you do performance tests for the third-party plugins, or would you expect that to do?
No, we do not do that, but yeah, it's possible to do it. What also we did not mention today that, of course, you can have your private repositories where you have complete control on what's there and what's happening. And if needed, we can share our test system with you. So I think we already did it with one company. So in this case, you get the ability to run your unit tests, your tests in a central kind of manner with a standardized view for the results. So that's another option. All right. Any other questions?
Andrew, you previously mentioned that you have some super column database embedded to the browser that can work in the browser. So is it something private or possible to take a look on this?
Yes. So it is our proprietary technology that we have not open sourced, at least yet, and there are no immediate plans for doing that. So it's written in Dart. Yeah, itself it's not open source, but the API to use it is open source. So you can use it through that JavaScript API that we provide.
But that is not available as a standalone component, right?
It is available as a standalone component through JavaScript API bindings. So in the beginning, if you remember, I was showing that data frame example where we have a Dart component, a data frame, and the binding to JavaScript and the API component and the JavaScript component. So this is actually the central class for our data engine. Of course, we do not expose any engine parts of it, and we have all sorts of binary serializers and stuff that work on compressors, things that work on compressed data, and other things. But you can use it via the API.
So you, as I remember, you mentioned that it can work on both front end and back end, right?
Right. So good question. Actually, the way it works on the backend right now is we run Dart code directly. So it will work if we run it in Node.js and compile our Dart code. Well, we already compiled it to JavaScript. We have not done it yet, so there was no reason for us to do it. But if such a need arises, we will provide some support for it as well.
Okay.
Okay, so if there are no questions related to the presentation, are there any comments regarding what we can do better, or are there any areas that you want us to describe in more details for the next time? And you do not have to answer right now. Please post your feedback on our community. We will be happy to talk over there.
Thank you so much, Andrew. Appreciate it.
Okay, great. Thanks, everyone. It was really good to see and hear you. So hope you find it useful. And yeah, please reach out to us.
Okay. Have a nice weekend,
Thanks.
everyone.
Thanks, Andrew. Same.
Okay, thank you. Bye.
Thank you.
Have a
Bye.
good one.
Bye.
Bye.
Thank you. Bye.
Thank you. Bye.